Good afternoon, and thank you for joining today's webinar from Spec Innovations, Getting Started with MBSE, a Data-Driven Approach with Innoslate. My name is Taylor Duffy, and I'll be the moderator for today's webinar. First, I'd like to go over some housekeeping. You can interact with us on LinkedIn through the Innoslate Users Group or through Twitter using the handle @SpecInnovations. The webinar is being recorded and will be made available to you after the live presentation, so keep an eye out for it in your inbox. Now I would like to introduce to you our presenter, Dr. Stephen Dam. In today's webinar, Dr. Dam will share the foundation of MBSE that allows you to easily track your system through the entire life cycle. Dr. Dam has been involved with research, experiments, operations analysis, software development, systems engineering, and training for more than 40 years. He has also received an Expert Systems Engineering Professional ESEP certification from INCOSE. He is currently applying systems engineering techniques to various DoD, DOE, and commercial projects. Feel free to send him any questions through the LinkedIn users group and send him an email to steven.dam@specinnovations.com. Now I'll hand over the controls to Dr. Dam and we'll get started.
Thanks, Taylor. So let's go through our agenda for today and talk about where are you in your life cycle. That's the first question you're going to ask yourself before you want to know where you're going to start. Then we're going to go through cases. The first one will be a top-down case, and we'll do a bottom-up and middle-out. And then you might even want to try to combine all three, depending on what you're doing. So we'll see how that works for you. Anyway, so one more is we're going to talk about where do we start with Innoslate itself. So a lot of people have two questions, right? They're asking, well, where do I start my project, and how do I start with Innoslate? So we're going to give you both today. So let's start with where are you in the life cycle? That's the thing people ask, well, how am I going to start? And then the usual systems engineer answer is, well, it depends. It does. It depends on what stage of the life cycle you're in. If you have a really, really good requirements document, somebody has done a really good job of setting that up for you, then the classic top-down approach that you hear about all the time, and it's the classic systems engineering techniques, would be what you will use. And we'll make that case number one. And then sometimes, though, you have like a legacy system you want to replace, or you're just trying to document the current system. That's where bottom-up works best, because you already have something, you can work with it and do more. And then that'll be case two. And so last but not least is that, and I've had this happen many times in my career, where I've worked kind of at the architectural level, that conceptual level, ACTDs, JCTDs, these kinds of things that are concept development things that somebody has a great idea, but not a lot more than that. So you, often there you're going to start with things that you have, like policies and procedures and things like that, and then this is what we call middle out, and we'll show you how that works. So the systems engineering process, the classic one, the one maybe you've seen many times on the right there, it has the requirements analysis, the functional analysis and allocation, synthesis, systems analysis, and control. So those are the typical stages that people looked at historically for systems engineering. And the funny part is a lot of people saw that as a waterfall. They would just go from one to the other, and that's top down. That's the waterfall approach, and people act like it's purely sequential. But if you notice, there's feedback loops all the way through here. So what it was implying was something massively iterative, and meant that you were going to be able to, and you could start anywhere. And so top down wasn't the only option. You had bottom up and middle out as well. You could work with, and of course, all three simultaneously. So that's that. So it actually it was what people are calling agile today. It was a very agile process, and it was kind of meant that way. In the, I don't know when this happened, but fairly recently, 15288 was put out by IEEE, and that just lists a bunch of processes, and it doesn't really tell you how to use them or when to use them or which is any kind of sequencing of the processes. So it's interesting, but I've never found that the 15288 was as useful as the other diagram. The top diagram to me gives me some place to start and work with. And so I've used it for a couple, actually about 3 decades now, and it's always served me very, very well. So let's talk about that a little bit more and look at each case. So top down. So top down, you start with requirements in some kind of form. Now, it just really depends where you are. Again, in the overall life cycle process. If you're at the top level, user needs, or I like to call them user wishes, because very often they aren't really specified in a way that's very clear or complete. That may be where you're actually going to do middle out and stuff. But if they've given you a pretty decent set of user needs, they've really thought it out. Maybe they've actually written up a full formal request for information or request for proposals even, and it has very detailed statements of what they're looking for. Then that's very useful. It doesn't matter what level you're at, but as you go down deeper into the system and the fidelity of the system, you'll get more and more defined requirements, and often many more requirements to work with. So down to the point where you may be at the component level, and again, we often call those specifications. And that's where somebody says, like an automobile manufacturer might be looking for a certain kind of pump, and they need a fuel pump of some kind, and it has to have very, very specific characteristics to fit within the engine system that they're building. So they give you a very detailed spec on that. They may even give you drawings and everything for it. But so really, really very detailed kind of thing you might obtain there. So again, those are places you can start with this requirements approach first. So the first thing we can do is you need a process, and so this is the process we use. Again, used it for quite some time. It's in all my books. So if you want to read details of it, you can go to the Real MBSE book. Probably is the newest and best rendition of this. But let me walk you through it a little bit just to help you. Again, you start with that source document, where that requirement is you got, and it could be, again, user needs or change requests. And maybe you also have data from other databases, some kind of interfaces with other systems and things like that. If you have that, that's great. That's useful. Then you're going to take and try to decompose what that statement was that they created. And again, it may not be a well-formed requirement, so you're going to turn it into a requirement. And part of that, as you're doing that analysis, you're going to probably identify maybe issues with it. And those issues may even have you spin off and create trade studies. Those trade studies, then any kind of issue resolution you should do with your customer. And by the way, that's one of the things I put in all my processes, is that customer in the loop step, because you always want to keep the customer. It's really what we call expectation management. You want to make sure they're happy in this whole process. So do remember that whenever you're developing one of these processes, think about where the customer fits in it. Well, then I have a diamond there saying, is the statement verifiable? That's actually, it's really it doesn't meet the quality parameters that you think make a good requirement. So verifiable is just one of those. But it's probably the most important one, because one of the things you're supposed to be doing, again, you want to coordinate any changes you're going to make to it to improve the quality. But one of the outputs of this would be to tie it to test requirements, or better yet, test cases. So if you can start building your test cases at the same time you're doing your requirements development, you'll find that the whole V&V cycle will go much faster, much smoother. Plus, you'll make sure that requirement really is verifiable. I have a means to verify it, so it is feasible to verify that requirement, and that's really important to be able to do very early on. By the way, that is the best practice that software development has adopted now with their processes for quite some time. So it's time for systems engineering to mimic software in that way, in doing it and speeding up the process. Of course, you're going to trace those to requirements to actions, assets, measures, other things that are in the system model you're going to be building. So that's going to be another thing you'd be doing in parallel. And then, of course, looking for risk. It's always important to look for risks and risk mitigation. People think risk management is a management problem. Yes, but risk identification is a technical problem. You, as the expert in the system, will be the most person who understands what those risks are and cost implications of those kinds of things as well. Okay, and then review your statements and risks with your customer. And again, hopefully you've got a knowledge base you're using to capture all this for that. So again, that's a databasing system tool like Innoslate. So how does Innoslate deal with that? So Innoslate has quite a number of requirements analysis features. First of all, there is a specific requirements view as part of documents view. So we have a special thing for requirements documents where we bring in the rationale, the quality score, and some other status information is there available. You also can see traceability indicators. That's what the STVs are. You see the little green things that say that. You can add comments here, things like that. So this has a full capability to create a hierarchical requirements document. And it looks like document form, but it is actually it is the individual objects in a database. So again, they're reusable. You can view them in many different ways. So this is really kind of a cool capability to have this. And it's really important if you're trying to get out of spreadsheets and into using a good model-based systems engineering tool. Another thing is our quality checkers. So we've actually been at the forefront of using artificial intelligence, natural language processing algorithms to look at quality. We had this in our tool for at least 7 years, so it's quite robust in its capability. It looks at specific parameters, and it can do. We have in the quality score roll up, we have 8 characteristics here, 8 attributes, but it only checks for 6 out of the 8 automatically. There's 2 it can't do automatically. Correct, which means is it legal, and feasible, is it possible? So those are the only ones. But the quality checker will, for the other ones, give you suggestions on how you can go ahead and fix the problem here with a little suggestion bar here. So anyway, that's some things, and we're looking to actually add even more improvements. There's some new technologies in LLP that we're looking to add here in the near future. Traceability, we have actually, this is another place where we use NLP. We have a traceability matrix, first of all, but then we have a suspect assist and a traceability assist, which is the traceability assist is the green, and the red is indicating suspects. And what that does is it reads the name, number, and description of each item, and at the top of it there on the chart is the actual verification requirements, and then on the left there is test cases. So we're checking that traceability between the test case and the verification requirement. One of the things we suggested you do early on in the process. So and so the darker the red means the more unlikely they should be connected. And the darker the green, the more likely they should be connected. So that's another thing about the NLP. It can actually give you percentages to give you a feeling for how close is it to something. By the way, the red may be an indicator actually of an incomplete test case or a requirement or something as well. So this is something, again, this is an analytical tool for you, the analyst, to look at it, the requirements analyst, to look at it and understand it and see where there might be issues and problems you want to address. Also, we have an intelligence view, which does have a section on requirements analysis specifically. And that, again, some more heuristics about what makes a good requirement. Things like using the word shall is usually considered to be the proper form to describe something as a requirement. Other people will take other words and feel that they're comfortable with that. But if you're very being formal with it, you want to have the shalls. It feels stilted these days to use a word like that, but it's okay. It's still good. Anyway, again, some of these things. Again, these are all tailorable, by the way, as you turn on or off these things or make them warnings versus errors. The red means an error. The yellow means it's a warning. And again, they roll up. And of course, there's other ones too in the global analysis you might want to look at, particularly if you're just looking at requirements. So if you just have requirements, you won't have some of these other panels, and you can actually get rid of them if you don't want them there. They're just widgets on a dashboard, which can be added or deleted from the dashboard. So again, that's requirements analysis for using Innoslate. So let's move on to case 2. So we're doing bottom up. Again, usually, this is an existing system, fairly well-defined subsystems and components, but maybe the documentation's out of date. That's not unusual to have happen over time. It didn't catch up with the mods that were performed, particularly if there was maintenance mods that happened. That may not have gotten put into the documentation completely. You may want to capture what you can from you're going to capture what you can from the legacy system, and then abstract the components to determine their functions. So you're trying to understand functionally what it is that system doing. Ultimately, you may decide to push those all the way back up to become new requirements, and then come back down and remodel, redevelop new processes, and then reallocate your functionality to an actual system. So again, that's the bottom up side of things. With that, I start with my synthesis process. So I don't end it there, by the way, but this is your starting point. And again, here we're looking at what are my components, how do they fit together. I can allocate them. I can look at trade studies. Maybe there are other components that I could improve with. And again, we always look at risks and do coordination with the customer as much as possible. Again, there's lots of ways to capture this physical information, and but ultimately you may come back up and create that functional model from it. So let's talk about physical diagrams from Innoslate. So we have an LML. There's an asset diagram, which is one of the mandatory diagrams. And then physical I/O is a diagram that's come in to play. We've used particularly for in Innoslate. The lines are indicating there's a solid line indicates that's the I/O. If it's gold, like they're showing there, it may be missing some information. I believe in those cases, it's missing the conduit between the two assets. So that may not have been defined. Other places like the dashed line, those are actual conduits that have been defined, which means there's no data element that's been associated with it. So again, this indicates that maybe I'm missing some information I would like to have to complete this diagram more effectively. And then here, ICD, actually one of my favorite diagrams. The ICD diagram shows you a detailed decomposition of interfaces. So here we have the payload bus interface being decomposed into data harnesses, the electrical ground, and the mechanical interface between the payload and the bus. So this actually gives you a lot of information. The gold is indicating that the units don't match with the data items. So that's not surprising, particularly on the bottom one. That probably should be 2 interfaces, because the data elements that with the units are not going to match the actual conduit units. So this would be something I'd probably break that up and put it into 2 different things. Okay, another one is the layer diagram. This is kind of a hierarchical decomposition, but flattened. So you see it as it's kind of laid out. This is, again, kind of thing people draw on PowerPoint all the time. So that we wanted to have that same capability to visualize it this way. And of course, you have hierarchy diagrams and things like that as well to use with this. For SysML, we do have both the IBD and the BDD. So those are both available if you like SysML. Okay, case 3, middle out. So middle out, you usually have a high-level concept or statement of need, and you don't want to use the current systems, or maybe you want to use them in a different way. Again, this is the kind of things like the JCTD, the joint capability technology demonstration. So that's a kind of thing that the Department of Defense uses to kind of take things that are existing legacy and turn them into something different and create new capabilities with it. And a good place to start with this is the processes and procedures. And there's lots of places, particularly in something like the Department of Defense, they have field manuals, detailed tactics, techniques, and procedures, things like that. In a business, you might have standard operating procedures that you want to use, SOPs. That's another source of this kind of information. And what we like to do is model these processes using functional analysis. And so the functional analysis process I have here is what we, again, used for quite a number of years. And it starts with the context diagram. So building a context diagram, even though that's kind of a physical diagram or asset diagram, it's how we do that. It's a good place to start with that. But yeah, that is something that really is part of that functional analysis. How does the system work in context with all the other players? What's the data flowing between them? That's a great place to start. Then one of the things I like to do is build a set of scenarios. These are they're often called use cases now. I've heard threads. You hear all these terms used for different things. So there really is a set of scenarios you're going to use for analysis. Very similar to what you do in a test matrix. You want to build this. You want to build this matrix of these scenarios to make sure you're fleshing out the functionality of the system. And so there's a little art form to that. And again, there's quite a bit of discussion in my Real MBSE book on that topic. Again, that might have you go off and do a lot of trade studies and things. But if you do the right way with the scenario development, you will end up creating a thing we call the system behavior model. And that's the overall model that then you can interrogate and use for almost any scenario. So that's a great way to do it. So make sure you do model all the scenarios, by the way, and simulate them. Make sure that they work before you push them forward, because I think it was that George Box had a great saying. He said, all models are wrong, some models are useful. Again, all models are wrong because they're abstractions of reality. So we need to make sure we're making them as realistic as we can. And again, don't forget your risk analysis as part of this process as well. So let's look at some of the Innoslate's functional analysis diagrams. The asset diagram for context is what we like to use. You can add backgrounds to it, pictures, lines, lightning bolts, So a lot of ways to make this pretty. Again, in DoD parlance, it's often called the OV1, the high-level concept diagram. That's a good one. For scenario modeling, we recommend the action diagram primarily. Of course, if you're using SysML, you can use the activity diagram. It's an equivalent diagram with it. We prefer this diagram over state diagrams. State diagrams are not as easy to work with as this is, and this is very clear, particularly if you use this LML action diagram. You notice you have these things. There's a loop there and an OR. Okay, so you know exactly what those decision points mean, and the beauty of that is, in fact, that is a specific type of action. We call them decision points, but it's a type of action, and which means it's allocatable to who or what does it. So I had a discussion with somebody just yesterday where they were asking me about how do you model the behavior of artificial intelligence. Well, I said it's the same way we model the behavior of people. And we've been modeling people like this using diagrams like this for decades. So it's nothing new. Anyway, and then, of course, as I mentioned, the simulators. Make sure you've got simulators that work and do what you need them to do. And of course, if you want to, you can add STK data and co-simulate with the systems toolkit, ANSYS systems toolkit, and use those geospatial constraints on the model as well. That can affect the timing of the processes and things like that. So lots of different scenarios on that. If you want to see some very interesting stuff, there's a YouTube video we have on our lunar rover project. So take a look at that. It discusses this in much more detail. Okay, so that's the first three cases. You may say, well, if what I'm doing doesn't exactly fit any one of those exactly. So here's something I found that works very well. Now, I often will call this my middle out timeline, but it's really kind of a combination of all three things. If you think about it, happening simultaneously. I'm capturing and analyzing artifacts and identifying assumptions. That's really part of requirements analysis. And similar as capturing constraints, those are all part of requirements analysis. If I look at the existing and planned system, that's part of synthesis. Remember, I'm looking for what's already here. And so again, you see how that's building off of these different things. Operational context diagram, again, is something both functional and physical in some ways. So there's some overlap between those different types. And then operational scenarios, behavior model. But now again, remember, as I'm doing any of these steps, if you take any point in time, I'm going to be doing quite a number of these steps simultaneously. That is really critical to have a database system to help you keep the data organized as you're doing this analysis. If you don't do that, you will be lost. You will be very lost. So be careful with that. Okay, so that's kind of how you start different projects. Hopefully that's good help with you for that. So how do you get started with Innoslate? So first of all, sign up for it. It's free to sign up for. You try the demo version and check it out. You just go to our specinnovations.com website and you click the down arrow on Innoslate that pops up with this menu here. And on the right there, you can see the sign up button in gray. And then, of course, we have a help center, so you can go there. There's all kinds of getting started things, views, dashboard information, widgets, simulators, tools, videos, on and on and on. Just lots of information here. Just search for what you're looking for, and it should help you find it. And then the guided tour. Once you start up, you're going to be put into this organizational dashboard. And so you'll have this guided tour button usually showing up for you. If not, there'll be a button on the side there to show it. If for some reason you turned it off or forgot to turn it off. If you've not gone through those guided tours, they really have been updated and they really are very nice for helping you get started with what you're doing. And of course, reach out for help. We provide help. It's just part of what the tool is. It's how we understand what's going on. It really helps us understand what kind of problems you're having and trying to help mitigate those problems before they become real problems. And you know what? Worst comes to worst, you can ask for training. And of course, we have lots of great training opportunities, including a workshop, which we highly recommend if you've got a fairly large project with a large team. This is very cost effective. So we can come directly to your location, or we can do it remotely and be able to do the training for you.
Thanks, Steve. We would like to thank you for joining us today. As a reminder, we'll be following up with you very soon to send you a link to the recording and the presentation slide deck. We hope you can join us for our next webinar, Issue Tracking, on July 19th at 2 p.m. Eastern. If you can't join us live, be sure to register to receive the slides and recording. We also encourage you to visit our website as well as connect with us on social media. That concludes today's presentation. Have a wonderful day. We hope to see you at our next webinar.